Hey, welcome everyone into the Wells Tech Garage for this week's training class, guys. Now, as many of you already know, we are covering EVAP, and this is going to be the last and final class for EVAP that we're going to do hopefully for a long time. We've talked about EVAP a lot lately, but I didn't want to leave off with the Chrysler system without finishing up some of these other systems that you guys are seeing in the shop. So sitting behind me here is a 2005 BMW 5 Series. I also have the fish tank setup over there with a Honda setup that we're going to talk about today. So I want to go over the systems and some of the intricacies of some of these other systems. So we're not going to cover the split purge seal system, the standard purge seal, any of the Chrysler stuff, any of the Toyota stuff. We're not going to get into any of that today, guys. If you don't know what I'm referring to when I talk about a certain system, make sure to go back and check out one of our previous classes where we covered that system in depth. If I were to try and do all that again today, this would end up being a 5-hour class. That is not the goal here. The goal is to hopefully you guys have the knowledge on these systems I mentioned already, and we're going to expand on that with certain differences between the vehicles, all right? So why don't we get right into this? I do have a lot planned today, and you guys are very active in the chat system already. So thanks, Keith, for sending out that link for the Vision Show. I just did want to talk about that quickly. Registration opened last week. It is a show and a training event. If you guys aren't going, it's definitely something that you should look into attending. I will be there. I guess Keith is going, and a lot of other people will most likely be there as well. Trainers are coming from all over the country. It's going to be an amazing show, so make sure to go out to that visionkc.com and check out that training show and get all signed up for that. Classes are filling up fast. Alrighty, let's get to the first of all t-shirt giveaway question. Now, guys, this is kind of a longer, wordy question this time, and I needed to make sure I covered a lot of different variables so that you guys, I want to get you guys thinking on this one, all right? So it's kind of a story. It's kind of a common replacement item. It's kind of a common diagnosis that people are using on their vehicles. And again, guys, you answer this question correctly, you can win a Wells Vehicle Electronics hat or one of our awesome Wells Tech t-shirts in either gray, blue, or black. I'll get that sent out as soon as possible. So you have to send me out an email by the end of the day. My email address is right here on the bottom of the screen, and I have to see that in my inbox before the day is over, so before midnight, before we turn over to November 10th. All right, guys, the question is, an older vehicle with a standard purge seal EVAP system is being diagnosed for a P0455 large leak code. The tech grabs a smoke machine and a scan tool and installs a smoke machine on the green test port and uses a scanner to close off the vent. The test passes. He's got no leak, no smoke. The pressure, the needle inside of there drops down below the 20,000th mark. It could even drop down to 0 at this point. Doesn't matter. He has no leak. He proceeds to cycle the vent numerous times, checking for an intermittent problem, thinking the vent might not be closing all the time, and he still doesn't have a leak. So he was good enough to watch one of our videos months ago when we talked about that Oldsmobile Alero, where you want to actually verify you have smoke flowing through the entire system. So he pulled the gas cap off and verified that he had smoke coming out of the gas cap, which means we have it flowing through our entire system. There's no check ball in the filler neck, so he knows he's testing the entire system for leaks. So what does he do? Goes out onto the internet and he inserts Silver Bullet website, whatever you want to use, whether you're on forums, Google, SureTrack, Identifix, whatever you guys are using, and it shows hundreds of repeated failures and reported failures of vent solenoids failing on this vehicle. So what does the tech do? He plays the odds. Replaces the vent solenoid because, quote unquote, the vent solenoid is failing intermittently, so he says. Clears the code, runs it out. A week later, that car is back. Same P0455 code in that vehicle. The customer is now not happy. What did the technician miss? What is the most likely failure for this problem, okay? And just a hint, guys, it's not going to be an intermittent vent solenoid, and the new vent solenoid that he put on is not failing either, okay? So don't give me that. I want you guys to think and tell me what you think is going to be what he missed in his testing and what the most likely failure is, okay? All right, let's get right into, this is just a little review here. These are the systems that we've talked about before. The first EVAP class, we covered standard purge seal and some Ford EONV. Second two classes we used to cover Toyota and all their complicated systems. And then the last EVAP class we did NVLD, LDP, and ESIM. So if you're not familiar with any of those systems, please be sure to go back and check out those classes where we include that information, because there's going to be some stuff today that is going to build upon those classes, okay? So again, I'm not going to get into this stuff, these review ones. Make sure to go back and check it out. So what we are going to cover today, we're going to start with the DMTL system, the Diagnostic Module for Tank Leakage System. It's going to be very similar in comparison to the Chrysler leak detection pump system. It's going to be mounted on the vent side of our EVAP system, and it's usually canister mounted. And as you guys can see here behind me on this BMW, if we get a close-up shot of this, you'll see that our valve here, our DMTL pump assembly, is mounted directly to the side of our canister. Now, commonly this part is replaceable separate of the canister, which is kind of nice because these things do fail. Now, this one on this 5 Series Beamer is sitting normally up inside of the wheel well up there. I've dropped it down for testing purposes for us to see it today. But you can see it's all covered in dust. All right, there's a filter on this system. All right, right here is an inlet-outlet filter from the canister side. Okay, so keep in mind if you're having restriction problems on these systems, or any system for that matter, check out that filter element and make sure that it's not plugged up. Okay, especially if you have flow issues when you're filling up the tank or something like that. You know, you're putting gas in it and the fuel's spitting back at you. Check out this filter for being plugged up. Your vent path is plugged, it cannot vent the tank out. Okay? You will typically find these systems on European models. DMTL is going to be common across the board for Beamer, Mini, Land Rover, Volvo, Mazda. Some Hyundai Kias run them. The most common is probably going to be an older Hyundai Accent, is going to be the most common. But you will find these mostly on European models. This does use a standard purge solenoid under the hood, opens and closes, PCM pulse width controlled for the purge solenoid. There is no standard vent solenoid on here, all right? It is going to be incorporated into our pump assembly. It is not going to have a standalone vent solenoid like you would normally see, okay? There's also no fuel tank pressure sensor. So again, kind of going off of that Chrysler system with no fuel tank pressure sensor, there is no FTP on this vehicle. Don't look for the PID. You're going to waste your time because there's not one. All right? This system is going to be normally vented, and I just wanted to take a second to call out to look for TSBs and reflashes for these vehicles. BMW especially, common to be setting codes for EVAP problems that aren't actually a problem. The parameters or something got changed in a reflash, and it's setting false codes, okay? So keep that in mind if you're diagnosing EVAP issues on a BMW. Look at your TSBs for any sort of reflashing. Let's just see what everybody's saying here. Oh, you guys are busy. Oh, Keith. My eyes aren't spaced that far apart, right? Is it normal looking? You and your theory on Wisconsin people. Oh, man. Awesome. All right. Okay. Let's get back to this. So the components in our DMTL system, in that pump assembly, is you're going to have an air pump motor in there that's going to create pressure in the EVAP system. The more pressure that's built up in the EVAP system, the harder that this pump is going to have to work. And that's the principles on this system. As we build pressure inside of our fuel tank, inside of our lines, inside of the system in general, the pump is going to have to work harder. The PCM is watching that work. It's watching how hard the pump has to work. It measures the milliamp draw on this pump, and it's looking for it to increase as this tank is filling up within a set amount of time, right? Everything on EVAP is going to function over time. So our pump milliamps should start to scale upwards as we build pressure inside of the system, okay? The PCM is measuring this. This is basically our threshold, or our, let's call it our fuel tank pressure sensor, even though it's not, but this is how the PCM is monitoring the system. There's a switching solenoid inside of this assembly. The PCM is going to command this to seal the system for the leak test. Again, this is a normally vented system, and the PCM will command this, ground side controlled, to command this thing closed to test the entire system for leaks. And then we have a heater that is built into this thing. This pump motor behind me here has a built-in heater, and the goal of this is to reduce any sort of condensation or freezing or icing of this pump motor. So today we're going to scope everything and show you guys how it all works. We may not see the heater operate because it's about 70 degrees here in the shop. But if it were cold out, chances are you will see this heater operate, as the goal is to keep this pump from freezing up, okay? Because there's variables involved here, and I'll get to that in just a second of the operation of this thing. But there are some interesting things that icing or something inside of this thing could cause some issues. So they've incorporated a heater. Kind of a smart design if you ask me. Our parameters, going to be pretty average from what we've seen on just about everything else. 15 to 85% fuel, ambient temp normal, about 4.5 hour cold soak. One unique thing here is that we have to have a full engine warm up prior to our cold soak. Prior to the vehicle sitting, we do need to drive this thing up to full operating temperature, and then it needs to sit for that 4.5 hour mark. And obviously our battery voltage does need to be above 11 volts, otherwise we can't run the pump because this thing is running key off, engine off, okay, after the vehicle's been sitting. Now, parameters may vary depending on make and model. These are just some of them that I pulled for this Beamer, but you'll see it on different makes and models, different parameters, okay? So basically, our leak test is going to consist of this. The parameters are set, the PCM turns on our pump. All right, our pump then is going to pump through a 20,000th orifice. What does this sound like? Sounds like Toyota's system, right? Where it's going to pump through an orifice first to calibrate itself, to put a threshold in there. Every time we do this, every time this test runs, it calibrates. Now, what is the benefit of this? Variables. We can account for different variables, either wear in the pump, resistance in our wiring, you know, whatever kind of variables, temperature, fuel level maybe, whatever variables are included in this, the calibration is done every single time this test is run for a 20,000th leak, okay? So the PCM turns on our pump, does not close our vent solenoid yet, it just turns the pump on, and it watches the milliamp draw on that thing. And at that point, without the solenoid being closed, it is pumping air through a 20,000th leak orifice, all right? So then it records that number, whether it's 20 milliamps or 30 milliamps, whatever it might be, it's going to record that, and that is now our threshold that we need to pass when we seal the system. So what happens then? The PCM turns on the solenoid and begins to pump air into our system. It begins to pump pressure into our system, all right? If our milliamps on that pump read higher than our threshold, we pass the test. There's no leaks because we built more pressure in the system than what a 20,000th leak would have. If our milliamps are lower than our threshold, only slightly, then we have a small leak, right? Our threshold was a 20,000th leak. That's what we have to pass per emission standards. If we're slightly lower, let's say our threshold was 30, and we're now only at 20 milliamps, that means we're leaking somewhere. We're not building enough pressure inside of the tank. Therefore, we have a small leak. If our milliamps are very low, that's where you're going to see the large leak code come up. Basically, guys, in theory, the better sealed the system, the more amperage it's going to take to pump this system up and build pressure in it, the higher the amperage is going to go. So what does this look like? Here is a graph that I drew up to basically show what we're seeing here, okay? The yellow line is our milliamp threshold. This is going to be a testing threshold that the pump goes through every time it runs. The PCM says, okay, you have to remain between 12 milliamps and 40 milliamps, otherwise I'm going to set a pump code that we have an issue with maybe the circuit or the pump is failing. So what do? We turn on the pump. Our DMTL pump is commanded on by the PCM. The milliamps of the pump starts to scale up right through our 20,000th orifice. At this point, let's say that this is 30 milliamps. Now our threshold here is a 30 milliamp level. Okay, so this purple line right here is 30 milliamps as we go across. All right, so the PCM says, okay, 30 milliamps is going to be my 20,000th leak. I'm good with that. Let's turn the solenoid on and let's begin to pump this system up. So now our pump is applying pressure to the whole system, so our milliamps are going to drop down a little bit. They'll never come all the way back to the bottom because the pump is still running. But we're going to start to build pressure in the system. And this reminds me a lot of a regular purge seal system where we're going to scale over time dependent upon fuel level and the volume of the tank. So we're going to build pressure in this thing, and if within our time window, whatever our time window may be, if we are able to cross our threshold, measuring in milliamps, we pass the test. If we're slightly lower, we fail for a small leak. If we're significantly lower, we fail for a large leak. Okay? Now I did draw it up a second way here. This way here, it's going to be the same test, but you can see that our threshold is different this time. So maybe this time our 20,000th leak only came out to a 15 milliamp draw on our pump, whatever it may be. As long as it's over the 12 milliamp mark, it's not going to code for this vehicle. So now we're running 15 milliamps. As long as our pressure surpasses that 15 milliamp mark, we pass the test. All right? So that's what it's going to look like real time on a leak test. Now, before we get to covering all these different manufacturers, I do have everything set up here ready to run through a leak test. Now, I originally tried to do this again with an amp clamp and putting it on the scope, but the milliamp draw was so low, I was unable to. I mean, we're talking 12 to 40 milliamps. It was hard to show on the scope. So what I've done instead is I've run the voltmeter or the amp meter in line to our pumping current. So any current that's flowing through the pump is currently flowing through our meter. So let's go ahead and turn this on. And we'll set this right there. You guys should be able to see that as we zoom in. Beautiful. And what we're going to do is we're going to go in now with the scan tool and we're going to turn this on. So let's go ahead and grab the scan tool and I'm going to go into our data. I'm going to go into functional tests. And we're going to go special functions and we're going to grab EVAP DMTL leak test. So it's kind of nice we can run the full leak test and we're going to run the tank leak test. But first of all, guys, I just wanted to show you the wiring diagram for this. Just wanted to check comments quick since I'm already over here. All right. Oh, Spanky's here. All right, D6 Spanky. Thanks for joining us. All right. Nick says, thank you for doing a European car. You know, I don't know what it is, but a lot of people avoid doing the European cars. Really, the information on this thing was a little bit hard to grab, but it wasn't impossible to find what I needed to build the class on this car. So it can be a pain, but this one wasn't horrible, fortunately. In your opinion, out of all the EVAP systems, which one seems the most straightforward to diagnose? I agree with Keith and Christopher. GM purge seal system seems to be the easiest, the most basic style system. I agree. All right, let's grab a wiring diagram. And I just want to show you how this thing's all connected up. So let's bring this up full screen, and let's take a peek at our diagram. Now, track diagrams, BMW runs them. They're kind of a pain to get to. This one was interesting. Like you said about happy that we grabbed a BMW, well, I was second guessing when I thought I couldn't find a diagram. Because you click on this, and I want to see an emission control system diagram, and it gives me this. Okay. But fortunately, if you go into drive, and then you go into motor electronics, and then you go into tank system leak check, and then you grab the DTML, it is nice enough to give you a really awesome diagram that you don't have to spend a lot of time going through. Thank God. So we got a 30 amp fuse, which obviously is splicing off into something else, whatever it might be, because 30 amps is excessive for a pump that's only going to run in the milliamps. But we're going to feed that down into a single power wire into our DMTL system, where we have a solenoid here, closing our vent, essentially sealing our system. We have our pump motor right here, and then right here is our heater, okay? So 4 wires going to our pump. So right now, I have this wire disconnected, and I have the meter running in between here to monitor the current that's flowing across this pump. The PCM is also watching it down inside here, watching that current. And then also, I have the scope hooked up here, and here, so we can watch the voltage levels of our solenoid and our heater and our power in, just because I thought it might be interesting to see. But again, we might not see our heater trigger because of the temp inside the room right now. Okay? Let's just make sure I'm not missing anything here, and then we'll get back to this. All right. Eric's here. Eric, better to have you late than never. Thanks for joining us. And apparently, Eric's buying cookies. Thanks, Eric. Send them our way. And you know, Solid is right, Eric. You deal with the EVAP stuff all the time anyway, so you probably know everything I'm going to talk about anyway. All right, let's get back to, we're gonna go to the scope now. Let's get this guy plugged in. Now I do have the key on already on here, probably killing the battery. Hopefully we got enough juice left. We'll get the scope plugged in. All right, let's take a look at what we got set up here. I have all three up on the screen here, and I just have them spaced a little bit apart so that we can see all three. These are all at 12 volts right now, or right around the 12 volt mark. If we put them all the same, you'll see they're laying on top of each other. I just wanted them spaced apart so you guys could tell. The blue channel, channel 1, is going to be our solenoid. That's going to be the solenoid that is turned on by the PCM to seal the system. Red is going to be our voltage into the system right here. This is voltage in, 12 volt power. And then channel C, green, is going to be the heater. We probably won't see this thing come off at 12 volts, meaning the PCM is probably not going to ground our heater and turn it on right now, okay? Let's now bump over to the scan tool. I know I'm all over the place, Dave, sorry. Dave's trying to keep up with the switching, but he's doing a great job. All right, beautiful, look at that. Scan tool and scope on the same screen, that's what I like to see. So we're gonna jump into the tank leak test. We're gonna run this thing through the test. Turn off the ignition, turn on the ignition. Wow, I did that fast. All right, I think it's kind of cool that Snap-on includes some of these parameters for running the test. I think it's kind of neat. All right, so we'll continue. All right, so before I click yes, I wanna have this camera up so we can watch the milliamperage, beautiful. And then we'll have the perfect lab scope up. We'll leave it at that. I'm going to keep my head out of the way here. I'm going to click yes. And now it says reference measurement in progress. So 28 milliamps right now, it's measuring the reference. And I don't know if you guys heard that click, but the vent solenoid just closed and our milliamperage changed. Also, look at the scope. We went from 12 volts down to 0, meaning the PCM has now grounded our vent solenoid or vent for this system. So now the scan tool is telling me that it's reading the 1 millimeter tank leak measurement. 1 millimeter leak would be equivalent to the 40,000th leak check. This would be the large leak check. Our solenoid is still closed, and our amperage here is at 23 milliamps. What was our spec again? 28, I believe it had hit just before for our 20,000th leak check. So right now, guys, we're building pressure inside of our tank, and now depending on fuel level and tank size, is going to depend on how long this takes to do it. But the PCM should understand what fuel level is and accommodate that time accordingly. So our vent solenoid is going to stay closed. You can see on the green channel our heater has not turned on, and I don't expect it to. So our pump is running, 24, 25 milliamps currently. And remember, guys, this happens key off, engine off. And actually, I'm going to get over to the other side here. I'm going to get my microphone close, and you guys might be able to hear the pump running. So it's very, very faint sound. The average customer, while it's parked in their garage, probably will not hear this thing run, but it is definitely running, especially when the wheel well fender liner's in here and the tire and everything is on. You probably won't hear it. So right now, the scan tool is telling me that we are running the 0.5 millimeter leak check, which is the 20,000th or the small leak check. And what we have to do now is we need to have this millivolt value cross our threshold. So just to show you guys we're building pressure, I'm going to go ahead and pull the gas cap, and we should see the millivolt level go down because I just released the pressure. All right, install it again, and we'll see this scale back up. So now if this doesn't scale back up quick enough, we're going to fail the test because it fell outside of the time parameters. I don't know what the time parameters are, but it's possible that just caused us to fail the test, or we might still pass. Hard to say. We're going to have to let the scan tool run the test and find out what happens here. So it's still telling me that the leak measurement has started. It's running the 0.5 or the 20,000th leak check. And I'm thinking this thing's maybe a little bit low on fuel, so it's going to take longer to build the volume of pressure inside of the tank. And I'm probably growing gray hair right now. This is almost as bad as watching paint dry. But I want to get through this test and just show you guys that we should get over our threshold. Or we're going to fail the test before it reaches the threshold because I took the gas cap off. See what happens. Dave, you want to swap out the lab scope for the scan tool? Perfect, thank you. So as you guys can see, we are reading the 0.5 millimeter leak check, and it is still currently running, so we are still within our time parameter, and we're sitting at 27 milliamp draw on this pump right now. And I think it first pulled 28, right, for the leak check. So if we can reach over 28, 29 milliamps, whatever it might be, this should be a pass. See, now this is the part, if Glenn was here, he'd start singing show tunes for us. I think he called me out one time when we were doing a video and I was singing the Jeopardy theme song. All right, so we're at 29 milliamps. I'm kind of expecting this will hit up and over 30, but let's see. I would think if I didn't pull the gas cap, we would have probably already passed the test, but I did, and so here we are. There we go, 30. And the vent just shut off. I don't know if you guys heard it click, but if we bring the scope back up on the screen, we can actually bring the scope up full screen. And then we'll see, beautiful. There we go. You can see our vent solenoid has shut off. And when that shut off, we get the DMTL leak test has complete. There were no leaks detected. So really, is it a super complicated system? I would say no. Is the testing of it a little bit different than the ordinary? I would say yeah, probably you're going to attack this a little bit differently. You can still smoke test it like normal. All you're going to have to do is make sure that you bypass the vent here, either with the scan tool or with some jumper wires, and close that vent up and seal the system. Smoke testing should remain pretty normal, okay? It's kind of nice. Everything is mounted right here. You don't have to go chasing down a standalone vent solenoid or a standalone fuel tank pressure sensor. You know, it's all mounted to the canister right here with a couple hoses going off to purge in the tank and the air filter. All right, so not super complicated, but something that we need to understand how it works, because this is the only system that we're out there measuring the milliamp draw on our EVAP system. Kind of unique, but I really like the fact that every single time it runs the test, it's re-upping the threshold, right? There's so many variables on the cars nowadays that I like when we can re-verify our threshold every single test. All right, so are there any questions on the DMTL system before I move on to some of the other systems? I don't want to move on if you guys have any other questions, because I have everything set up here. So if there's anything else you want to see, I also have the whiteboard off to the side if you guys want me to draw out some pictures or something. I mean, you know, my artwork sucks, but if there's any confusion on this, I want to clear it up now before I move on. So let me know real quick if there's anything else here that you want to see. All right, let's see what you guys are saying. Eric's wondering how Keith got the blue wrench. I decided it'd be a good idea to throw a moderator on here this time, just in case, because our comment section has become very popular. I just didn't want to have to deal with it, so that's why Keith has a blue wrench. It hasn't been a problem yet, but I want to hopefully have Keith catch it before it ever becomes a problem. So I'm just going to copy and paste the comments really quick, guys, so I don't lose any of these, because like I've said in the past, and I will always say, I read every single comment after the video. YouTube is just not very nice in the fact that they delete some of my comments for me. So I want to just capture those quickly, and let's see if there are any other questions before we move on. Is there an EVAP test port? On BMW specifically, or across DMTL systems, I would think you're going to see EVAP test ports. I looked for one on this 5 Series under the hood. I did not see one. But because this is a EVAP system that's just hooked up to a purge solenoid, there's no reason that you can't, first of all, verify purge operation, but then unhook the hose off the hose and hook your smoke machine in right there. All right? So that's what we're going to do normally when we don't have a test port. You could also buy the fuel tank cap adapter for your smoke machine if you would want, but most people are going to go ahead, pull the hose off the purge solenoid and hook that in there. All right, thank you, Keith. I appreciate the donation there. Thank you. Thanks for supporting us. All right, Hector's here. He hit traffic, but he's here. All right, your brain is digesting it all. All right. Uh-oh. Keith's getting out the delete button. And Enzo Molinari, I apologize if I'm mispronouncing that, but you know, with this video, it will be published right after this. So if you need a little bit more time for your brain to digest all of this, definitely check it out afterwards. You can pause it wherever you want and grab the information that way. Can you get a false positive with a seizing pump, Caleb asks. Let's think about this for a second. Could a seizing pump cause issues? Well, our threshold is redone every single time, right? So the chances of it seizing on the testing side versus the threshold side, I would think would be unlikely. If we're going to seize up, we would most likely see that seizing on the initial threshold and then also on the testing. I don't think we're going to bypass, I guess it's possible, but it's unlikely. And also with a seized up pump, don't you think the amperage would probably potentially spike out of our threshold, out of that 12 to 40 milliamp window? Just a thought, I don't know. But I don't see how a seizing pump could cause an issue. I think there's a way that a technician could falsely pass this test. Not the right thing to do, but I think there are ways to fool this system into passing the test, but I don't think a seizing pump is going to falsely pass this test. All right, I hope I answered that for you. And Caleb, if you want to know more, if there's more to the question, let me know. Either shoot me an email or comment in here, and I'll look into it more and answer it during the Tech Connect episode at the end of the month. All right, thank you, Wyatt. Thanks for the donation. I appreciate it. All right, that's awesome. All right, guys, I think it's time to move on to, we're going to go by manufacturer now. I'm going to cover a bunch of manufacturers. I'm not going to cover everybody because, again, we've covered some. Some are repetitive, and then I'm not going to get into things like Lamborghini or Maserati or Ferrari because chances are most of us are not working on that. I'm going to cover the main things that we're seeing come into the shop by us, and most of you are probably seeing come into the shop by you. If you're working on a Ferrari, good for you. Chances are you probably already know how the system works. But if you don't, you can maybe apply this to your Ferrari. All right, let's start going into the manufacturers. Let's see what we got here. We're going to start with Hyundai and Kia. Not something we've touched on before. If you want to bring this up on the screen, Dave, that'd be great. We're going to start here. And we touched on it a little bit with that Hyundai Accent at first, where it was running the DMTL system on that old Accent. Many of the newer Hyundais are running a standard purge seal. You can see here our system diagram, pretty basic. You know, we got our fuel filler cap going into our tank, our fuel pump assembly, some rollover valves, a vent valve going to our canister, the purge valve PCSV coming off of the engine. I like how it's called a purge control solenoid valve. Just some funny wording. Is it either a solenoid or is it a valve? I guess it's just kind of interchangeable. But purge solenoid mounted directly to our engine or with a hose to our engine, pretty simple. And then a CCV or canister close valve on this side. But again, guys, we got a fuel tank air filter here. I believe there's some TSBs or recalls out there actually for Kias. I remember doing them when I worked at the Kia dealership on Sorrentos, where we were actually replacing this. I don't remember if it was a TSB or if it was a recall, but we were replacing these air filters on those things because they would plug up and cause EVAP issues or refueling issues. All right, the reason why this screenshot is up on the screen here, guys, is because I wanted to just talk about very quickly the amount of information that is given to us from Kia. Now, this is obviously out on all data, but I just really like the fact that you could look up P0455 information and you could find all of this information here. I really, really like the information that they share with us. I think it's really nice that we get all of this info. You know, not like some Europeans or even some domestics now that are getting harder to find info on. Also, guys, when you're working with Hyundai and Kia, just note the production of the vehicle. Was it produced in the U.S. or was it produced in in Korea, excuse me? Because they are going to have differing wiring diagrams, okay? The TF and the QF Optima uses different wiring diagrams. You're going to find different colors on your diagrams, whether it was built in Korea or whether it was built in the US, okay? So keep that in mind when you're messing with these things. If your wiring colors don't match up, chances are you're on the wrong production of the vehicle, okay? All right, here is a leak test from a 13 Optima 2.4 liter non-turbo motor. Pretty standard leak test. I mean, this is what we've seen all the time. Our purge solenoid opens, at some point our vent solenoid closes, and we're just watching our fuel tank pressure sensor. Pretty basic, but I did want to call out over here all of these nice parameters and information over here. And I also like the fact that they use the word under pressure. Check fuel tank under pressure during evacuation. Can't just say vacuum, they got to say under pressure. Just funny wording that they use. But I like the fact that they include all these specs for the enable conditions. And then I like this, these thresholds and diagnostic time. I really like that they're giving us the time limit of these windows and the specs for what they're looking for, okay? You know, as a technician, we're always looking for specs, whether it's a torque value, a test time, a setting condition. We're always driven off of numbers and specs because that is the only way that we're going to be able to duplicate this exact, well, not this one on a Kia most likely, but the exact testing conditions and parameters and test. Sometimes when you're using a scan tool, it's not going to do everything exactly as the vehicle would test it. Few and far between, but it's possible. So you have to set the test up yourself. Well, on a vehicle like this 13 Optima here, they're nice enough to give us all the specs that we could build the test ourselves with a set of jumper leads and a stopwatch. Really, that's all we would need. We'd have to monitor fuel tank pressure, jump our vent, jump our purge, have the engine running, and have a stopwatch. That's all it would take to run the test on this because they give us all the parameters. I think it's great that they include this, and that's why I have that up on the screen there. Okay, now let's get to another European vehicle, VW and Audi, or whatever you're going to call it, Volkswagen and Audi. Many of these are going to be running a leak detection pump system similar to Chrysler, okay? Some of the newer systems are going to be using DMTL, and some of them are most likely running a standard purge seal system also. So I guess the moral of that story is make sure you verify your service information before you go tackling a Audi or Volkswagen EVAP system. I wouldn't say every model of this uses this or every year of that uses that. I would be looking at service information every single time because there could be mid-year cutoffs or something like that. But chances are older ones are going to run LDP. Some of the newer ones are going to run DMTL or purge seal. All right, just a little bit on their LDP. It's going to be done key on engine running, just like Chrysler did. Vacuum is key for this. It's needed to pump this system. Just like on Chrysler, again, if you guys haven't seen the Chrysler class, make sure to go back and check that out, where we talk about LDP and how it says that it's a pressure pump, but actually the vacuum is drawing the diaphragm up and down, creating pressure in our system, okay? This is going to operate the same way. The PCM is going to watch the fuel tank pressure sensor and the cycles of the pump on and off, and it's going to cycle the pump on and off. And the PCM is going to watch that cycling rate of the reed switch to check for leaks. This system is tested with pressure, okay? It is normally vented, and most of these, and the key word here is most, do not use a standalone vent solenoid. It is going to be internal of the LDP. Here's the internals. This is going to be almost the exact same as the Chrysler one that we did last time. So I'm not going to spend a lot of time on this, but basically we have to have vacuum coming in and this diaphragm moves up and down to create pressure inside of here. Also, when vacuum is applied, it's going to seal the system, essentially creating a vent valve effect. Okay, some other differences with VW Audi. They might have a pressure holding valve in line between the tank and the rest of the system. Now, I'm not going to dive into this too deep, but it's very similar to Honda, which we're going to cover in a few minutes when we get over to the gas tank. So it's going to have that. The difference is this one might not include a parallel bypass solenoid. It might only be mechanical, okay? I'll explain that in just a minute. Also, watch out for check valves on the purge solenoid hose, okay? A lot of Volkswagen and Audis are turbocharged vehicles. We have to have some sort of check valve on that purge line, because think of what would happen if all of a sudden this car was purging and you suddenly got on the boost, right? You hit the pedal and the turbo spooled up and now we got a ton of boost in the intake manifold. What if that purge solenoid was open at that moment? Could we potentially push 8, 10, 12, 15 PSI into the EVAP system? Scary. We could end up splitting seams, blowing hoses. I mean, there's so many possible things that could happen if this check valve weren't there. So they put a one-way check valve in this line to verify that that doesn't happen. But think of what happens if it fails, okay? Just keep that in mind to look for that. And also be careful on wiring diagrams for these things with the naming of the solenoids. Trust the numbers, don't trust the translation, okay? So an N80 in a wiring diagram is going to be our purge solenoid, okay? An N115 is our vent solenoid, and a V144 is going to commonly be called our leak detection pump, okay? N80, always purge, N115 is vent, okay? Keep that in mind. They might switch up and say an N80 is a vent. Well, that's not right. The N80 will be the purge solenoid, okay? Here's what I found interesting with some of their LDP systems. We have some model year breakouts for the same name, right? LDP, 09 to 10, and 11 and up. It looks to me like we have a 3-wire system here and a 4-wire system here. What's the difference? We have some ohm values. I don't really care about the ohm values. If you guys are testing this, you can ohm it out, sure, that's fine. What I'm caring about here is the fact that we have 3 wires on this one and 4 wires on this one. This looks to me like an 09 and 10 of this model is running an LDP, leak detection pump system. Looks like here, a 4-wire system, 11 and newer, we're running a DMTL system. We have our pump, we have our solenoid, we have our power in, and we have our heater circuit, okay? That's what the LDP is missing. It's missing the heater circuit. That's why we went from 3 wires to 4 wires. For proof, here's our wiring diagram. N80, purge solenoid over here in the circle. N80 is always going to be purge. I hate using the word always. I would say, is most of the time going to be the purge? I would say benefit of the doubt, N80 will be purge. I'm sure there's one example out there where the N80 is something else, but if you see N80, it's going to be purge. Then we get to V144. This is our leak detection pump, as called by Volkswagen Audi, but this is actually a DMTL pump, okay? We have power going into it. We have a solenoid and a heater, or vice versa. It's hard to tell in this diagram. And then we have a pumping motor in the middle, okay? So keep that in mind. It might be called a leak detection pump, but that's not truly what it is. Here's some parameters that I had just found related to some of the different testing. I think it's interesting here, the signal current, 2.2 to 4 amps. Is a pretty significant current for our vent solenoid circuit. But I also thought it was interesting that the PCM is monitoring the vent solenoid current. Kind of interesting. Just thought it was cool that they called that out. And you know, it just, again, we're looking at specs. I like to look at specs. I like to see numbers when I'm testing, and it's nice to have this. So even though it's a Volkswagen or an Audi, you can find specs like this. Don't think it's impossible to find. Okay? Before we get to Mercedes-Benz, let's just take a quick peek at the comments, see if I need to answer anything for you guys. All right, Keith is saying, Barone has a nice question. Let me scroll up. What protects the system if the pump shorts out? That's a great question right here. What protects the system if the pump shorts out? Mike, I assume you're talking about the DMTL system like this one behind me. You know, I'm thinking that this PCM has current limiting built into it. I would think that it's going to have some sort of resistor or something inside the PCM that is going to current limit this thing. So if the pump does short out, that you would not burn out the driver in the PCM, especially on newer stuff. Older stuff might be hit and miss. You might burn out a driver on the PCM. But how do you check that? You look for control, right? You throw a lab scope on it, and you see if the PCM's commanding it on and off, right? What are the requirements for running this test on the scan tool, coolant temp, fuel level? You're going to find that that'll be different make and model, but typically they're pretty much consistent with that 15 to 85% coolant temp, depending on if it's vehicle off or vehicle on. Will usually be normal operating temp or under a certain temp to match with intake air temp. All right. 06 Sorrento 3.5, that is a new timing about water pumping goodies. All right. Never trust. Oh, that's good. Good stuff, guys. You can actually have the comments up on the screen here, Dave, while I'm looking at this. How would a clogged filter cause EVAP issues? Christopher, clogged filter. Now we're going to talk on EVAP filter. We're not talking air filter. Even though they could be commonly labeled in a diagram, we're talking EVAP system filter, like this guy right here. The EVAP system needs to breathe. After it's made its way through the canister, after it's made its way through the vent solenoid of valve, whatever it's using, it has to be able to breathe in and out fresh air. It needs to be able to expel air when we're pumping fuel into it, or it needs to be able to suck air in when it's drawing vacuum on the system. This filter could cause the fuel nozzle to shut off. So you're pumping gas in, that pressure has to go somewhere. Did you know that when you're pumping in gas, that's what shuts the fuel nozzle off, is pressure buildup? After you get to a certain level of fuel, this system is basically sealed, and there's a pressure buildup inside of the filler neck that actually shuts the pump off. Okay? So if you have no way for your pressure to escape through the filter, if this filter were plugged up right here, no way for the pressure to escape, your fuel filler nozzle is going to be constantly clicking off. You're not going to be able to put any fuel in this thing, right? You're going to get 20 cents in and 20 cents in and 20 cents in. You'll eventually be able to fill it up if you stand there long enough and click it enough times. But if you were to just sit there and hold it down, there's a possibility that you shove enough fuel in there, that pressure needs to burp out of there, it could actually force fuel back out at you. So that's probably the most common failure for a plugged up vent filter. Otherwise, you could end up with some issues with the vacuum side of things, but I would say that's less likely. The usual first complaint is the fact that the customer cannot put gas in it. Let's see here. All right. Homie Hector's got a point. Raise your hand if you got a question. Yeah, that's the only downside to not standing in front of a classroom, is I'm not able to see you guys raise your hands and, hey, I got a question over here. So I rely on you guys to keep it up in the chat. If you have a question, keep bugging me. I'm going to look back every few minutes, 5-10 minutes in between. So I do scroll back to answer these, because my goal here, guys, is I don't want to leave the class today, because I have everything set up. I don't want to leave the class today not answering all of your questions. And then at the end, I will also ask if there are any additional questions. Okay, let's get to Mercedes-Benz. Mercedes-Benz uses a lot of the purge seal systems, basic purge seal. There are a couple little differences. The vent solenoid can be called a canister shutoff valve or canister shutoff solenoid, and they will sometimes also run a vent valve. This vent valve is going to be similar to the bypass valve that we're going to talk about on Honda in just a few seconds, but it's basically a pressure relief valve that's mounted between the tank and the canister, and we'll get to why that is in just a second. I think this is interesting here, guys. We got a V12 over here, and it's got 2 purge solenoids. Kind of cool, right? Kind of cool, but could potentially cause some headaches. So let's think about this for a second. Our engine, a newer engine, computer controlled, has purge solenoids, 1 for each bank. Maybe each bank is, most likely each bank is going to be individually controlled. This one actually might, being that it's split manifolds here, it might even be controlling 3 cylinders at a time for fuel trim with potentially very, very many air-fuel ratio sensors. Hard to say, but my point here, guys, is we have 2 purge solenoids. Think of what happens if the computer commands those open, okay? Let's take a little trip here. So our EVAP canister is full of fuel vapor at this point, right? The computer says, okay, I assume we have fuel vapor sitting in our canister that I need to get purged out of there. I need to get that drawn out so that I can store more. So what do? I open up the purge solenoids. Now I'm smart enough to know that when I open up my purge solenoids, I'm going to have some fuel vapor entering into the engine. So what am I going to do? I'm going to maybe cut back a little bit of fuel preemptively. I don't want to cause a rich condition. I don't want to cause any sort of issues. So I will most likely pull back some fuel before or while I open up our purge solenoids on either side. Depending on the system, it might wait to do that until it sees oxygen sensor responding. Hard to say, but let's just talk in theory here. Let's say that one of those purge solenoids didn't open. Okay, so you have 2 purge solenoids connected to a single line going to the canister. We got a ton of fuel vapor rushing up to the engine, being sucked out by engine vacuum. Now we have one that's closed and then one that's open. So in theory, the one that's open over here could be sucking in a ton of fuel vapor, double what it normally would be if this guy was open over here. Now this one's not open, not drawing any vapor. In theory, could we have a very split fuel trim for this engine? One bank stuck closed, running incredibly lean, and the other bank stuck open, running incredibly rich. We could have this varying difference between the two banks with having two purge solenoids. It's just something interesting that we need to remember in our diagnostics, that things like this can happen, okay? Depends on how the computer reacts. If it's a Mercedes, who knows? They might be just watching O2 sensor response for the purge solenoid to open. Don't know. But just in theory, something like that could happen. That would be more interesting than just a standard single purge solenoid drawing into the engine. So just some more variables that we have to worry about when we get into some different engines like this. Also guys, when you're working on these things, pretty much any vehicle really with saddlebag tanks, where we're going to have a tank on either side, if it's got two fuel level senders going to the gauge or something like that, make sure both of them are functioning. Otherwise, it's not going to run the test. It's going to need input from both fuel level senders. So if you have a monitor that's not running, make sure both fuel level senders are functioning. Most likely you'll have a check engine light or at least a code, but that can cause some issues. And then here is just a 03CL500 diagram. What's interesting that I found in here is that it's showing a V12 here, right? 6 cylinders per bank, but this is only a 5-liter V8 sitting in the CL500. So don't trust this diagram or this engine picture here. Most likely it's just a generic picture. But here we got Y58.1 is our purge control, and Y58.4 is our activated charcoal canister shutoff valve. That's what they want to call it. I don't care. All we care about is that it's got some way to seal the system on the vent side of the system, hooked up to some sort of wiring. Standard purge seal at that point, guys. Okay, Honda and Acura. They're going to do things a little bit differently, and that's why I have it all set up over here. We'll get to it in just a second. I want to talk through it first. Just a quick review of the comments, make sure I'm not missing anything. Enzo, my email address should be in the description of the video below here. If you do have further questions, feel free to email me. I'll answer them. Hector is your illegitimate son, huh, Keith? That's awesome. Good for you guys. Whatever you say. All right, let's get to Honda and Acura now. Okay, Honda and Acura, many times on most of the newer vehicles, is going to be using a standard purge seal system. Basic run-of-the-mill, tested the same way that you would. On older stuff, late 90s, early to mid 2000 models, you will find that they're going to use a purge seal with a bypass that's going to split our system up, similar to the way that Toyota did for the intrusive and non-intrusive systems. It's going to be similar to that, but it's going to, similar but different, I guess is going to be the best way to describe it. But the best way to figure out what system you're dealing with is look at a wiring diagram or system description to figure out if you're dealing with a bypass system or a normal purge seal. So why does this matter? Why do we care about this bypass? Well, the testing operation of this is going to be a little bit different for this. Our normal purge seal system testing is going to, if you were to test it like you would a normal purge seal system, it will most likely throw you for a loop and get you to replace the wrong parts, and we don't want that. So why do we run a bypass? Well, the goal was to seal the fuel tank. If we can seal the tank and it builds pressure inside of it, the tank will not create as many fuel vapors. You know, we talked a little bit about this when we talked the Toyota hybrid system that they're using, about being able to seal the tank off, and it's going to reduce vapor generation. Because when we turn on the purge solenoid, it wants to draw a vacuum on the system, right? Our goal is to suck fumes out of our canister. But if we suck on the tank as well, we're going to create a vacuum inside of there. We're going to create a place for vapors to grow, right? We're going to suck all this out of here. Now our vapors are going to have somewhere to grow, and we're going to create more vapors inside of the tank. If we had a way to seal that side of the system off, in theory, our vapors would generate with less volume. Okay, so that was the goal of this bypass system. It's going to use a mechanical and an electrical solenoid, a mechanical valve and an electrical solenoid to make this happen. All right? So normally this valve is going to be closed. Mechanical and electrical will be closed. It's like a parallel system, and in fact, we'll get it up on the screen here in just a second. Key note, the mechanical valve will open on this thing from the tank side. I need you guys to remember that. Burn that into your brain. Tank side of the system at 7 inches of water, pressure, or vacuum. Okay? Burn that in there. Tank side only. Okay? Remember that, because that's going to be coming up here in just a second. It's only on the tank side that it's going to relieve this pressure or vacuum. Okay? And the bypass solenoid, the only reason why the computer is going to turn that on is if it is testing the system for leaks. So here's what it looks like on paper. You know, pretty crappy picture here, but basically we have our tank running to through some hoses to our a couple valves here, but going to our bypass valve right here. Fuel tank pressure sensors mounted to our bypass valve. We have our canister, we have a purge valve, and then we have a canister vent shut valve. So purge, vent, and this bypass stuck in the middle. It's important to note, guys, our bypass and fuel tank pressure sensor are prior to our canister, okay? Here's what it looks like in pretty colors that I drew out on PowerPoint here. This purple dotted line right here is the split in our system. So our fuel tank side and our canister side. Here's our bypass valve right in the center here. We have a mechanical side of it, and we have an electronic solenoid side. This is basically a parallel style valve with two different options to allow flow through it. We can turn it on with a solenoid, or we can overcome a mechanical valve inside of here, okay? Fuel tank pressure, see where this is, guys? This is where it becomes important. You see this, what I'm circling right here? Fuel tank pressure is on the fuel tank side of the system. What does this mean? This means if we go to this vehicle looking for a leak or testing the system for whatever reason, if we start this thing up and apply the purge solenoid, even with the vent open or the vent closed, I don't care which way you're going, you can apply purge to this entire side and you can still have pressure in your fuel tank. Okay? The only way we apply purge vacuum or engine vacuum to the fuel tank is if our bypass solenoid is open. Remember before I said the fuel tank side is what we're going to allow pressure or vacuum to leave from. This two-way mechanical valve will allow pressure or vacuum to bypass this plane right here. Okay? So if our tank ends up in vacuum or ends up in pressure, we can flow through this valve. If our canister side of the system ends up in pressure, let's say we put our smoke machine in right here, right after the purge solenoid, if we end up in pressure on this side, we can bypass this two-way valve. But we cannot bypass this two-way valve with vacuum. You could suck on this side of the system with a vacuum pump or engine vacuum all day long. As long as this mechanical valve in here is intact in proper operation, you will never draw vacuum on the fuel tank pressure side. On the fuel tank, where fuel tank pressure sensor is mounted, you will not draw vacuum on there until you open up your electronic solenoid of your bypass, okay? So think about what that's going to do for our testing of this system. If we want to measure this system and put vacuum into the system, if the PCM wants to measure this system, it's able to do it in two parts. First of all, what's it going to do? It's going to apply purge, shut the vent, and it's going to look for that fuel tank pressure sensor to not change because our bypass should be holding. If all of a sudden our fuel tank pressure sensor starts to go down or starts to show vacuum inside of our tank, our bypass valve is failing, right? Because the computer has not turned on the solenoid yet, so our solenoid is still closed. The mechanical valve at that point is failing. The computer's able to figure that out by testing these two different halves. Okay, so it passes that part of the test. Now we move on to the second part where we're going to draw vacuum on the entire system and test it like a normal purge seal. So now we turn on the purge, we close the vent, and we turn this bypass on. Now our system is fully connected from purge to gas cap. We can draw vacuum on this entire thing and our fuel tank pressure sensor will respond. Normally we're going to test it as a normal purge seal system at that point. It's that simple. The bypass in the center is what throws you for a loop, and I'll show you guys what we're going to see here in just a second. So again, just to reiterate, system purging, the PCM opens it up, duty cycle, vacuum is drawn on the canister side, and the vapors are drawn into the intake manifold. It will not draw vacuum on the tank. The leak test, like I mentioned just a second ago how we went through it, but fuel tank pressure sensor on this thing is going to be roughly at atmosphere about 2.5 volts. After a cold soak or a hot soak, we should see this thing off of the 2.5 volt mark, right? If our tank is sealed, if our bypass is closed and our tank is not leaking, we should not have atmospheric pressure in this thing if everything is sealed up. If we show atmospheric pressure, we have a leak. Whether it's the bypass, a hose, the tank, the filler neck, the gas cap, I don't care. It doesn't matter. We have a leak on the tank side of the system. Or the bypass is opening the entire system up, so we could have a leak in the purge or the vent or the canister or all the hoses in between. Basically, our fuel tank pressure sensor should not read atmospheric if this thing went through a hot or cold soak. I went over all of this. Interesting note, usually you can force the monitor to complete with the scan tool, and smoke testing or pressure testing will overcome the mechanical limit of this two-way valve from the purge side. What does that mean? Again, you're putting smoke into this side right here. You can overcome the pressure relief on this two-way valve, and you will show pressure on the fuel tank pressure sensor, but you can draw vacuum on this thing all day long, and all it's going to do is make it seal up tighter. It's not going to allow vacuum to transfer. Okay, here's what it's going to look like in a little graph. Fuel tank pressure sensor 2.5 volts at atmospheric, and right now you can see we have we'll call it a little bit of pressure inside of here, and that pressure is going to grow because the vehicle's running. It's next to some hot exhaust. So here we start our leak test. Vent solenoid is turned from off to on, and our purge solenoid is turned from off to on. We should still see a gradual increase in our fuel tank pressure because the fuel's getting hotter. We're going to build pressure. If we saw a decrease here, if we saw this go down, that would mean that our bypass is leaking. Okay, that means we're applying vacuum to our tank side, which is a bad thing because the bypass is currently turned off. Okay, so our vent is still on, our purge is still on. At some point here, the computer says, okay, I'm happy with that. Let's open up the bypass. Now we're taking the system from two halves and creating a hole. Purge vacuum will be applied to the tank. The system is sealed, and we draw the system down into vacuum over time dependent upon fuel level and within the time thresholds. At some point here, we should hit some sort of threshold that tells the computer to turn the purge solenoid off, leaving the system sealed. With the system sealed, again, we're going to watch it over time just like a standard purge seal test. Now usually on these systems, I know I didn't draw the back half of the test, but usually, usually you will then see maybe the vent solenoid come off and watch that fuel tank pressure sensor return quickly to verify blockages or lack of blockages in the system. Okay, now before we get to Honda's EONV system, let's head over here and I'll show you guys what I've got set up. So of course, the rubber duckies are back. One of them is having a better day than the other one. The other one's drowning over here. But I have this whole system set up. Now, the difference here is this is not exactly a full Honda system. This is a little bit of a mishmash of parts that I had laying around. This is a Honda bypass solenoid right here. If we can get a close-up shot in here, you can take a look right here. This is our bypass solenoid. You can see our fuel tank pressure sensor is mounted directly to our bypass solenoid. Our FTP is right here. This is a GM FTP. This is the one that I've been using the whole time for the class, guys. So this will scale opposite of most. When we build vacuum, we'll increase in voltage, and when we build pressure, we will decrease in voltage. This is a GM style vent solenoid. Doesn't matter. All I'm trying to do is seal up the system, and then we do have a GM style canister. Doesn't really matter, guys. All we're trying to do is demonstrate the system. The only difference between a standard, let's call it a GM purge seal system, and a Honda bypass system is this guy right here. This is what throws everyone for the loop. So let's show some testing with this thing. All right, so first of all, what are we going to do? The engine is going to go into purge mode, okay? So right now we're going to start purging on this system. And those of you who have done a lot of EVAP testing know that typically when you turn a purge solenoid on, even with the vent solenoid open, you will typically see some sort of slight reaction on the fuel tank pressure sensor. 1.735 volts. Not changing whatsoever. And of course, we're not building vacuum in the system because our vent is open still, but usually on a standard system, you will be able to see a small amount of change, but we're not going to because what did I say before? Our bypass is in the middle of the system right now and it's sealed. Our tank is its own unit right now. We can draw vacuum on this thing all day long and we will not create vacuum on our tank side where our fuel tank pressure sensor is mounted. All right, let's take this one step further. Let's turn our vent on. And you guys probably heard that click. Our vent is now sealed. So now our purge, our vent, and our canister are all sealed up to our bypass solenoid. So again, what am I going to do? I'm going to start drawing vacuum on this system. And try not to release all our vacuum. But you can see that my needle is definitely moving up. And I do have vacuum inside of the vent, canister, and the hoses in between. Where I don't have vacuum is at the fuel tank pressure sensor right now. Because our bypass is still closed, we are still sitting at 1.35 volts. Okay? We will not see vacuum on this side until the PCM says, okay, let's open it up, and there we go. All that vacuum that I had, actually we got a leak here by the vacuum pump. Now we can draw the entire system into vacuum, and now we're going to test it just like a standard purge seal. We're going to draw it to a certain threshold, and then we're going to stop. We're going to shut the purge off, and we're going to let it sit. And it's got to remain at a certain amount of vacuum for a certain amount of time. And this system's not perfectly sealed, as you can see. We are leaking slowly. I have connections here that aren't secure, so I did expect to see some leaks. Is it going to stay there? It's probably going to fall off. Okay, so we definitely have vacuum on this side of the system. Now, if we turn our bypass off, we still have vacuum in our tank until we release the vacuum by pulling the gas cap or something like that. We go back to normal. Now, that is from the purge solenoid side. So if we're pulling vacuum on this system through the bypass, we won't get through the bypass until we turn it on, right? But we can, with the bypass off right now, I have bypass off, it's unplugged, I still have our vent solenoid closed. If the tank were to go into vacuum, if we were to build a significant amount of vacuum on this system, it is possible to overcome our mechanical valve in here and allow the system to breathe through the entire canister. So what I'm going to show you guys here, I still have the vent closed, so we're going to draw vacuum on that whole side. So I'm going to turn this vacuum pump on. This would be just like if our tank was going into vacuum. You'll see our fuel tank pressure sensor move, and then you'll see this needle start to move. And there it's coming off of 0. It's probably about 3 inches of mercury right now, roughly 3 inches of mercury through our entire system. So what that's doing is that it's allowing our tank to breathe. And you can hear but what's interesting now, I have vacuum still on the purge side. I still have vacuum inside of this. You can hear it, but our fuel tank pressure sensor is right back to normal. Because the tank is now lower vacuum than the rest of the system. The canister side cannot draw vacuum on the tank. The tank can draw vacuum on the entire system. The entire system, or the canister side, cannot draw vacuum on the tank, okay? I guess that's the general theory behind this, guys, is just don't get burned when you're testing this thing, okay? Don't hook up your scan tool. Don't turn on the purge solenoid with this thing running and expect your fuel tank pressure sensor to move. It's not going to. There's a blockage in the way. There's a door in the center of that system that is not going to allow vacuum inside of that tank, okay? The tank can breathe either direction, and you can smoke test from the purge side through the system, but you cannot use purge vacuum to test the system unless you've opened the bypass solenoid, okay? I hope that makes sense. Let's see if there's any questions revolving around that. Joe, the bypass is going to be normally closed. It will be normally sealed on this system. What madman kills a rubber duck? You know, Dave there sitting running the switcher right now, he's a big duck hunter. I don't know that he would kill a rubber ducky though, but he's a big duck hunter. All right. The wide-eyed people. You guys are killing me. My eyes can't be that wide apart. Keith, look what you've started. All right, Joel, see you next time. Make sure you come back and watch the rest of the video. We're Probably got about another 15 minutes or so in this, and then we're all done. So let's bump back to Honda's last system they are using on their standard purge seal. Many of them are now using an EONV. Very similar to Ford. The car does have to pass the large leak test, key on engine running. So again, opening up the purge solenoid, closing the vent, drawing the system into vacuum, like always. But our small leak test is going to be done key on engine, or key off, engine off. Okay? PCM is going to remain partially active. We're going to close up the vent after a certain amount of time, and we're going to watch for pressure or vacuum build up inside of the system. Now, I thought this was interesting that Honda is looking for a 0.3 kPa pressure or vacuum increase or decrease inside of the tank. I thought that was just a crazy, crazy number because crossed over to PSI, which is something that I understand more, that's 0.043 PSI. That is less than a tenth of a PSI is all this thing is looking for, right? That's all it's looking for to verify the system for a small leak. So if there's no vacuum or pressure change, well then it must know that the system is not sealed and it's allowing that pressure or vacuum to escape through whatever hole it might be. But if there is a pressure or vacuum change, all it's looking for is 0.0435 PSI. Crazy small number. All right, Nissan and Infiniti. They're going to use a lot of things similar to Honda with their bypass system on early models and then a simple purge seal on more recent models. You're going to obviously diagnose the purge seal like you always would. The bypass system is going to be functioning a little bit different than Honda, and it was used up until about 2004. The vent solenoid may be called a drain solenoid on a Nissan. Just keep that in mind when you're looking at a diagram. If it's called a drain and it's got two wires going to it, it is a vent solenoid. Fuel tank pressure sensor may be called the EVAP system pressure sensor. Still same old. And many times in Nissan and Infiniti, they interchange valve and solenoid. Basically, look at a wiring diagram and see if there's wires running to it. If you see a system diagram with a valve that you don't find in the wiring diagram, well, chances are it is a mechanical valve, not an electronic valve. So Nissan's bypass system, the way that it differs from Honda is not in the components, it's just in their operation and their values. Their components are very, very similar. Nissan does not isolate the tank, though, during the leak test, and you will not see a specific tank or canister side code. When the monitor is run, the bypass is open, drawing vacuum on the entire system. And the bypass is only being used to hold a slight pressure in the tank during the vehicle's operation, again to cut down on fuel vapor production. The cut valve on this thing, or the bypass valve, or the relief valve, whatever you want to call it, operates at a much lower tank side pressure or vacuum on this thing. Their goal isn't to build up 7 inches of water. It is much lower on these systems. Its goal is to limit the amount of flow of vapors, not so much the vapor generation. It's not really sealing the tank. It's just basically limiting the amount of flow that can happen out of the tank during a normal vehicle operation. Obviously, during fuel filling, there's going to be a valve that would open to allow that pressure to escape. All right, here's the basic system, and here's that relief for refuel. It runs right directly to the canister hose. So during certain situations, you would see this. This would open during refueling to allow that fuel to exit. We go from our fuel tank up to two parallel valves, the vacuum cut bypass and the vacuum cut valve. So this is going to be just those little doorways in between that are operating at a much lower pressure or vacuum level. The difference here, guys, is look where our fuel tank pressure sensor is mounted on here. See this? We are on the other side of the door on Nissan and Infiniti. Okay, we are measuring pressure, and that's maybe why they call it an EVAP control system pressure solenoid, not a fuel tank pressure sensor. Excuse me, EVAP control system pressure sensor, not solenoid. But maybe that's why they're calling it a system pressure sensor instead of a fuel tank pressure sensor, is because we are on the other side of the door here. In theory, we are not measuring, until these valves are opened, one of these valves are opened, we are not measuring the entire system, we are only measuring the canister side of the system. Okay? So keep that in mind. Nissan and Infiniti is going to operate fuel tank pressure sensor different than Honda. The system is similar, the location of the FTP is what changes everything. Okay? All right, this is just calling that out. So similar to the Honda, except pretty much the opposite fuel tank pressure sensor readings. Here I'm talking about pulling the gas cap while watching fuel tank pressure, and you could see that you might not get any movement because the bypasses are closed. And also on some Nissan Infinitis, you will see a fuel temp sensor, and that's going to be used to help calculate vapor generation. Hotter fuel is going to generate more vapor, potentially, than colder fuel. So here's the basic leak test for a Nissan system. The bypass is going to be right here. And similar, our fuel tank pressure is going to sit somewhere around 3.3 or 4.2, and then we should see that drop as our system is opened. Okay? Mitsubishi. Oh, must have missed the header page. Okay, Mitsubishi, going to use mostly purge seal systems. One major thing is watch out for that vent filter for blockages. These are all the parameters. I just wanted to list them up here so you guys could see what it takes to run the EVAP test. I'm not going to go any further into this. Besides, I want to call out 3 different things. One, it's looking at volumetric efficiency of this vehicle before it's going to run the EVAP system. I thought that was interesting. 25 to 80% VE. The other thing is that this will not start the test until at least 16 minutes after driving. I don't know if 15 minutes just wasn't adequate, but 16 minutes is their spec. And then also you do need to be going more than 18.7 miles per hour. I don't know why it couldn't be 18 or 19 or 20 or 15, but 18.7 is their spec. You know, these engineers designed these specs for a reason. We got to follow them. Make sure you're going more than 18.7 miles an hour if you want to run the Mitsubishi test. This is the system diagram for Mitsubishi, pretty basic. Purge solenoid going into the intake manifold, coming from our canister right here. FTP, fuel tank pressure, is mounted directly to the tank. We got some pressure regulators and some valving in here for rollover, and we got a liquid separator coming from the filler neck. Nothing too fancy here, pretty much same old, same old. And then right here is our vent solenoid, normally open, closed for testing. And then our right here is our air filter. So just again, make sure that if you are testing one of these systems that's building up pressure inside of it when it's not supposed to be, make sure you verify that EVAP system air filter is operational. Subaru. I think this might be the last model that I'm going to cover. Subarus, first of all, guys, are going to be notorious for a lack of information on the scan tool. I played around with a 2010 Legacy, and I was a little bit surprised at the little bits of information they gave me. I could run a leak test with the scan tool, but that was really about it. I was able to see a fuel tank pressure PID and a vent PID, but that was about it. I didn't have much for control. I didn't have much for testing on the scan tool. So just know that on Subarus, they are going to be notoriously bad for scan tool parameters. And I did try multiple tools and was not very lucky with systems on there. Most Subarus will run a purge seal system. The purge, again, is PCM operated. They can call the vent valve or vent solenoid a drain valve, similar to what was that Nissan that was calling it a drain valve, or somebody else was calling it a drain valve. Same thing here, vent equals drain, same thing. Then we are going to have a PCM controlled pressure control solenoid. This is the same thing as the bypass that's running on Honda and Nissans and some of the other models. It's again going to be PCM controlled. It's going to open and close depending on the situation. Again, this is going to be a normally closed valve that the PCM opens during leak testing. Subarus have a lot of purge solenoid issues. That purge solenoid can be hard to get to on that boxer motor. So there are usually a steel line coming off of them with a rubber line that then goes to the rear of the vehicle. Sometimes instead of getting to the purge itself, if you are able to activate it with the scan tool, pull the rubber line off the steel line and do your testing there. Whether you're checking to see if the purge is leaking or functional, you can do it there instead of having to get underneath the intake manifold to get to that thing. So just a quick little tip on that. Here's some parameters for leak testing. I thought it was interesting they were calling out air-fuel ratio with some huge skews in numbers here, 0.76 to 1.25 lambda. 1 would be stoic, 14.7 to 1. So I thought it was interesting how much wiggle room they were giving AFR here. especially because if this thing is setting rich or lean codes, it's not going to run the EVAP test anyway, so I don't understand why they care about this, but they do. Apparently they are watching it before you run the test. This is a precursor for this. Also, we're at 75% here for fuel and 25% instead of 15 and 85, so keep that in mind. All right. Okay, guess what, guys? That's the end. Whew. The end of EVAP, or at least the end of these live EVAP classes. I think I've pretty much covered every single style of system out there for EVAP. I'm sure there's some other one-off systems that I haven't covered with some intricacies that are going to have to be addressed every time you look at them, but the majority of the systems have either been covered in depth, like the Honda or DMTL, or briefed over like the Subaru we just talked about. You guys should have all of the tools at your disposal for tackling most of the EVAP problems that come into your shop. We got 5 separate classes now on EVAP of live training classes, and we have a handful of other quick EVAP videos. In fact, guys, I think I'm going to be putting another shorty little quick testing EVAP video out here in the next couple weeks. But our next live class, we will be again on December 7th, which is Pearl Harbor Day. But it is December 7th for our next class. And we're going to do something different. Again, probably a case study of some kind, or 2 case studies, depending on what they come out to be. Probably playing with the scope and the scan tool, and having some fun. So that's the plan for that. I got a pretty interesting counterpoint video, guys, coming out next week, Tuesday. It's going to be a 2-part counterpoint. The next video will release next week, Wednesday night at 7 p.m. So make sure to check those out. I think you guys will like what you see on those. It's an interesting little study that I performed, a little experiment. Okay, let's get caught up on the comments quick and see what you guys are saying, see if you guys have any more questions. At this point, guys, if you do have any more questions about any of the systems that I've covered, if you want something else demoed, now is the time to ask. I have everything set up. I would be happy to run through something else right now. Otherwise, shoot me out an email or comment in here and I will get it answered. If I don't know the answer, I will get back to you by the time I release the Tech Connect video with that answer. Okay? All right. Enzo says too much information, system failure. Shutting down. Ooh, Tesla EVAP. Random gearhead, if you can find me a Tesla, if you can get a Tesla in here for me, I would be happy to discover the Tesla EVAP system and see. But you know what? I don't think you're going to find an EVAP system on a Tesla. But if you can find one, you let me know. All right. I wonder do those batteries have any sort of gassing principles on an EVAP, on a Tesla? Like a ventilation type of system for those? Is that a sealed system on there? I know on a lot of other hybrids they just have a fan that's blowing air in and out for cooling. But if you put a battery, like a standard 12-volt battery under the seat of an old Buick or something, they always had those vent lines on there. I wonder if there's any sort of vent system for the batteries on a Tesla or any other full electric car. Definitely not my specialty. Lacking knowledge on Teslas. I've never worked on one, never even gotten to drive one yet. Maybe someday. I've heard they're fantastic vehicles. Are there any websites that offer diagrams on how these systems work similar to the ones that you've drawn up? Mike, most of this stuff is going to come out of the factory service information, whether you're getting it off of AllData or Mitchell or Identifix or right out of the book, like that Porsche one that you sent me. That's where you're going to find most of this stuff. Otherwise, you got to take what they give you and you got to build it yourself. That's a lot of the graphs that I built are all just built off the knowledge that we know from the system, what it's doing. And then we don't always have all the parameters, but we can draw something that makes a little bit of sense. I got a whiteboard sitting right next to my desk. When I'm working through a system, that's what I do. I draw it up on a whiteboard and see if it makes sense. See if the test parameters make sense and look for things in there that might cause problems during that test. So I don't know if you're ever going to find all those diagrams in one place, especially for free, but typically you will find them in service information. Interesting. No word for solenoids in Japanese. It's good to know, Keith. Nick asks, what motivates me to do this class? That's a great question, Nick. The motivation comes, well, first of all, because this is my job. I get paid to do this. I am a technical instructor. That is my title. I'm paid to instruct, so that's motivation in itself. But seriously, just sharing information, helping everybody become a better tech is really what motivates me. You know, I'm a huge proponent for training, whether it's in the classroom, whether it's on YouTube, whether it's out of a book. I don't care how you guys are getting training. I want everybody to be able to have access to training in whatever manner that they want to be trained in. This is the manner that we offer. YouTube is our resource for that, and that's what we're going to use to train you guys the best that we can. You know, our goal is to go out there and train technicians and help you guys have a better day. So if you're diagnosing a DMTL system on an 055 series, or you know, whatever you're working on, hopefully you're able to learn from this class today and apply that to future diagnostics for you. So I guess to say training and helping out other technicians is what motivates me, because I spent almost 10 years wrenching on cars full-time, working flat rate. I know how much it sucks when you get a system in like a BMW 5 Series that you've never dealt with before and have no knowledge on, to spend the time to diagnose that accurately and efficiently. Most guys turn them away because of the time that it takes to develop the knowledge on the system. So I'm hoping in this now hour-and-a-half class today, you guys have enough ammunition that you aren't afraid to tackle a DMTL system on a BMW or a Land Rover or a Mini Cooper or whatever might come into your shop. I hope that you guys just dive in and go after it and use the information that we've shared in the class today. You can always go back and watch the video and refresh yourself. So tomorrow you got a Land Rover coming in, watch the video today. If it's got a DMTL system, chances are it's going to operate like this Beamer, okay? So I guess, in short, that is my motivation, Nick. So thank you for watching. I agree with Keith, paying thousands of dollars for classes over the years. I've had factory training from Kia. I've had thousands of dollars invested into me for factory training at the dealership level. I've paid out of my own pocket to go to training. I've been paid by the shop to go to training. Really, we just all need to get trained. I think at the end of the day, I like this avenue because it's free for you guys and it's always accessible on the internet, okay? Just be careful if you're looking for training on YouTube to pick out the good guys. As strange as that sounds, there's a lot of people on YouTube and a lot of videos on YouTube where they're doing things that you don't want to mimic in the shop. Wire nuts, for example. It just bugs me. Wire nuts on a car. I've seen multiple YouTube guys making videos using wire nuts when they're wiring something up. It drives me nuts. Don't use wire nuts on cars. Autonomous vehicles, Terry, I really want to get into something autonomous. I want to play around with it. I want to get a Tesla in here that's running that autonomous system, whatever they're calling it now. Cadillac's got a new system out. I really want to play with it. I want to figure out how exactly it works and the intricacies of it, because I think it's fascinating. I think it's just really cool stuff. I think the future is going to be very interesting for the automotive world here. EX Motorsports asked if I could start over. I got in late. You know, my throat's already starting to hurt from all this talking. I should have grabbed a bottle of water. So no, I'm not going to start over, but you can start back at the beginning of the video. On any of these systems, have you ever seen a purge valve open during a leak test? Well, Hans, the purge valve has to be open at the beginning of the test, right? But then it should close. Forcing the test to run, usually I can clamp off the purge valve to seal it off. And on this Audi, I found the LDP builds pressure, but the N80 starts to run. Car always, that's interesting. Forcing the test to run, you can clamp off the purge to seal it. Well, it depends, I think, on how the LDP system is getting vacuum. If it's a true LDP like a Chrysler system, it needs vacuum to operate. Is it using the purge line to build vacuum to make the diaphragm inside move up and down? Is it using the purge for that? I don't know off the top of my head if they're running a separate line like Chrysler does that's just full intake vacuum or not. But that's a great question. All right. Wire nuts, Chris. Wire nuts. More. Is my accent showing? I had a guy the other day leave a comment on a video asking if I was from Minnesota. Definitely not. But I guess people from Wisconsin also have an accent, as well as our eyes are apparently spaced too far apart, according to Keith. Hans, I'm gonna look into this a little bit more for you. It's a really interesting question. I'm not sure on the answer, and I don't want to give out an answer that's wrong. So I'll look into this a little bit more, and if I can find some information for you, I'll be sure to bring it up in the next Tech Connect episode and let you know what that answer might be. All right. It looks like that's going to be about it, guys. The chat slowed down. I think I'm pretty much caught up. I will again review all of this and see if I missed anything. Again, guys, if there was any other questions that you had and I've missed it, either chat in now or send me out an email or leave a comment on this video afterwards. I will be sure to go out there and answer them personally myself. So, the question for the t-shirt or hat was up at the beginning of the class. If you missed it, make sure you go back, read through that, send me out an email with your answer. You get yourself a hat or a blue shirt or a gray shirt, or we also have black, depending on what you choose. I think that's going to be about it, guys. So, as always, please check us out on social media, Facebook, LinkedIn, Instagram, and Twitter. Search for Wells Vehicle Electronics, or follow the links that are below in the description of this video. If you've missed any of our EVAP classes and you kind of didn't understand what the reference was in this class to a previous class, make sure to go check them out. Again, this is the 5th EVAP class that we've done now, and this will be the final full EVAP class. I was sort of joking, but that is good for you to say that you're looking into it. I would be here for that, okay? Great. All right, guys. So thank you, everybody, for watching. Thanks for being here with me for an hour and a half. I hope you have learned more about EVAP than you ever wanted to know, because I know I have. Can you put, yeah, sure. Enzo, I'll throw my email up on the screen right now. Could you bring that up for me, Dave? That is me. Go ahead and send out your questions to that email address right there, and I will be sure to answer that out for you, or send out the answer to the tech question. All right, so Nick says thanks for your time. Thank you guys for your time. I appreciate having the opportunity to stand up here in front of you and train you guys, and I think that's going to be it. Next week, Tuesday and Wednesday, the 2-part counterpoint video will be coming out. I think you guys are going to enjoy it. I had a lot of fun shooting it. Until then, guys, we will see you next time. Oh, one other side note. I don't think Mike Burton is in here right now. He might be still. But that was the viewer. If you remember last class, we talked about the Porsche Cayenne that he was working on for the timing correlation codes. He did email me with an update on that thing. It is fixed. It's on the road, and the money lights are all off. So good for him. I want to give him a round of applause for fixing that thing up, because he's not a full-time tech. He grabbed his lap scope and his wrenches and whatever else, and he tackled that thing himself in his garage at home. So good for him. He's got it back on the road and running. All right, he is still here. Awesome. Great. So awesome, Mike. Nice job on that. All right, guys, I'm out of here. Thanks for watching, and make sure to check out the videos that come out next Tuesday and Wednesday night. We'll see you guys next time. Happy wrenching, everyone. Thank you.